In the Huggable project, we use MSRS primarily as a convenient way to interlink the separate subsystems inside the robot. In the following slides, we will show how the complicated connections between the subsystems are organized through the use of MSRS. The Huggable contains an embedded PC inside running Windows XP embedded. On this PC, there are several MSRS services that are used to collect and process low-level data. Some examples include a vision frame grabber, which captures images from the cameras inside the eyes of the Huggable, a virtual somatosensory cortex that collects and processes all information from the skin sensors, audio processing, which records data from the microphone array, IMU processing, which gives information about the orientation, translation, and movement of the Huggable, and internal temperature feedback. All of this data is passed over a wireless link to the rest of the system. Using MSRS saves us from worrying about networking issues such as IP addresses. Here, the data is collected and stored at the shuttle PC. This data will then be passed over to the behavior system and the remote operator. With the help of MSRS, we have a built-in web server for the user to remotely view the processed data. This link between the remote operator and the web server is modeled as a solid red line. The remote operator connects to the Huggable through a web browser using the built-in web server from MSRS. On this website, the user will be presented with a variety of input options, as well as visual diagnostics. This is the main screen the remote operator sees. This entire window is generated through an MSRS service which combines the visual feedback from the Huggable, shown up top, and the 3D representation of the Huggable, shown below. Using MSRS gives a performance increase in rendering speed and decreases development time of Internet-ready video streaming. This red rectangle is the result of an MSRS service wrapper over OpenCV, which performs high-level face detection processing. Since MSRS is built on the .NET framework, creating such wrappers is easy. As you can see, MSRS allows the entire diagnostic screen to be accessed from anywhere in the world by using a simple website interface. This is an overview of the software internals of the Huggable. The embedded PC performs many low-level data collections and sends this information out to the rest of the system. In this diagram, you can see the number of interactions we have created using MSRS. The end goal is to combine all of the incoming data into an easy-to-use website for the remote operator to access. Here we present all that is required on the end user's computer to show the website screen, visual feedback, and send data from the Xbox 360 controller. This is an overview of the MIT Media Lab C5M behavior system architecture for the Huggable robot. Using incoming information from the MSRS services, the behavior system creates an accurate model of the real world. This architecture then selects the appropriate motor and audio output for the Huggable based upon this input.